Hello, we're getting ready for experiment 4. Just like if we were on campus, remember that your pre-lab and data observations are due on the same day. And then the post-lab is due after that. In this case, it's going to be 12 days after, and all of these times are at the end of the day. Please see me during office hours to talk about experiments, lab reports, any of this. This would be a good time. Also activities to get feedback on those things. As I mentioned when we were on campus, this course is heavy, backloaded, so you can see experiment 5 coming April 22nd, experiment 6 coming. Oh yeah, there's an exam in here. So there's a lot going on. So please keep up to date, keep up with the deadlines. Email me if you got questions. If you are thinking about withdrawing from the course, the date is May 8th. So please let me know if you got a question about that. There's a quiz for experiment 4. The quiz will be on Canvas, so you'll get instructions about that. The topics that we're going to highlight today come from that last activity. We're going to talk about solutions, what happens when ionic compounds are dissolved, and we're going to talk about molar conductivity. Those are the keys for experiment 4. Experiment 4, even on campus, is a very short experiment. You have plenty of time to wrap up the post-lab, to finish up all the data. But you could also start working on that pre-lab for experiment 5 as well. So this week, activity 11 and experiment 4 with quiz 2. So when we think about solutions, for sure we want to be comfortable with drawing the chemical equations for when the ions dissolve. So this was part of the activity, and this is looking forward to the experiment. We have sodium chloride in the experiment, and it dissolves into the ions 1-to-1. We also have calcium chloride, and can see that calcium's 2+, and it dissolves into chloride, but really pay attention here to the stoichiometry, because that creates 2 chlorides. Okay, so we're definitely going to highlight in this experiment the stoichiometry. Is there 1 chloride? Is there 2 chloride? Is there 3 chloride? But you should definitely not overlook the cation. In this case, this is an acid. So this is a strong acid, so it would also fully ionize. And it's real easy to see and think, well, there's 2 chlorides and 1 chloride, so this is going to have a higher conductivity. Don't forget the cation here also contributes to the conductivity. So we'll take a look at that on the next slide. So here's the equation for molar conductivity. Remember, it's talking about the amount of cation and anion, and then we look up the values from the table. We don't need to know these values. We just look up the molar conductivity. They could be given to you on quiz, exam, but you use those values. So from the slide before, calcium chloride, we look and see calcium's 0.1190 Siemens per molar centimeter, and then the chloride here, 0.07635, and there's 2 of them. Well, the hydrochloric acid definitely doesn't have as much contribution from the chloride, so that's less, but look at this significantly different number here for the molar conductivity of the cation. Again, stoichiometry is 1-to-1, but you can see HCl is a lot more conductive than calcium chloride, so it's not just based on the number of anions, but it's also taking into account the cations. So this is what you'll see in experiment 4.